The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseWare continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseWare at ocw.mit.edu.
Let's get started. How about the spring weather?
Oh, yeah. Tomorrow. It's the end of April.
Tomorrow.
Someone needs to tell New England that it's the end of April and it's time to warm up.
Yes, it's getting boring now. We need the spring weather to come quickly. All right, good, great. So let's see. So today we have the pleasure to have Professor Noelle Selin to give a lecture. And Professor Selin is not only a professor in the Engineering Systems Division, but also the Department of Earth, Atmospheric and Planetary Sciences. So Noelle, her PhD was on modeling of air pollution, and has been doing lots of work on how to develop, on understanding policy related to air quality and pollution, specifically on mercury. And through that work, she has observed first-hand international negotiations of policy, basically how the sausage is done, I guess, of policy making, where you really see all the parties getting together, and the role of science, and ultimately how this affects how to do that at the global scale. And as we have been talking throughout the course, one of the aspects that is new from a business perspective as you get into environmental topics is you have to interface more with stakeholders that are not the traditional ones. So last lecture, you had a chance to hear from EDF, NGOs. EDF is of the nice kind of NGO. From a business perspective, they want to engage, but there's others that attack. On the policy front, as a company, you also need to understand what kind of shape could the policy take in the future, and what is the role of business, how could this impact business, especially how it impacts supply chains that are global. So with that, Noelle, the floor is yours, and thank you for coming.
Great. So I want to say right off that I don't know much about supply chains. So I'm hoping that this can be very much a discussion. I'm hoping to learn from you guys as well as talking to you a little bit about Mercury. How do I do that? Can you hear me now? Okay.
Yes.
All right. So why is the case of Mercury interesting in the context of sort of international business supply chain regulation? Well, Mercury is the most recent global environmental treaty. So the Minamata Convention, which is an international convention on mercury, was signed just this past October 2013. And it is widely thought of as it's the first real new global environmental treaty in over a decade. The previous one was also on a chemicals-related topic, the Stockholm Convention. So it's an example of international environmental cooperation of which we don't have a lot. We don't have a lot of concrete stuff coming out of the climate negotiations right now, but this is a brand new agreed global treaty. And it's widely thought of as the first entire life cycle international convention. So I'm going to talk about that in that context and sort of how it emerged, what some of the science behind it is, and how it might influence, thinking about chemicals regulation in a product context, because products are a core area. Mercury in products are a core area of mercury regulation under the convention. I'm going to talk a little bit about the interface as well between domestic regulation in the U.S., international regulation in the European Union context, which sort of is a sub-global regulation, and how that interfaces with the global context. So that's sort of where I'm planning to go. Please feel free to interrupt me if you have questions or want to go in different directions. So what I'm going to start with is just a little bit about sort of the scientific background. So we're kind of on the same page on why we're concerned about mercury, why we're having a global treaty on mercury in the first place. The reason that mercury is a global problem is that the mercury that we're emitting doesn't stay within our borders. So the main criteria for having an environmental regulation internationally, there's a general principle of international law. You can do whatever you want within your own borders. If you're ruining your own environment, it's kind of your problem. But the minute you start ruining other people's environments, that's when it's subject to international concern. So if you just emitted mercury at deposited right next to your power plant or something and contaminated your local environment, it wouldn't necessarily be subject to international regulation. But mercury in the atmosphere is in a pretty volatile form. And mercury, when you're emitting it to the atmosphere, lasts for about a half a year to a year. So that means it blows around. And it blows around pretty much globally. If you think about, watching the weather map and how far weather goes in different winds, you get about 7 to 10 days to go across continents, basically. So in about 6 months, you can imagine that this something that lasts in the atmosphere that long is going to mix pretty effectively. Interhemispheric mixing time is about half a year to a year as well. So anything emitted in the northern hemisphere is going to go to the southern hemisphere too. So mercury all over the world in the atmosphere. Now, the reason it's a problem is because of what happens when it rains out. When it rains out, it accumulates in ecosystems. It turns into methylmercury. Methylmercury is even more toxic than mercury. It builds up in food chains. Goes into little fish. Big fish eat the little fish. In the Arctic, there's a really long food chain. Polar bears eat the big seals. People eat seals. You get high levels of a neurotoxin of concern. So methylmercury is a neurotoxin. It has effects on people's IQs, in particular pregnant women who consume things high in mercury, particularly fish. During pregnancy, their offspring have neurological impacts, even at sort of background doses, lower IQ outputs. So this comes from a range of epidemiological studies. More recently, lest you think, all of you might be off the hook, cardiovascular impacts in the general adult population. So mercury is bad for everyone, not just pregnant women and kids. I'll talk a little bit about gold mining communities. Mercury is used in artisanal and small-scale gold mining. And mercury itself, at really high levels, can also be very dangerous if you breathe in too much of it, but not really acutely toxic in the concentrations that we might likely be exposed to. So although it's a concern to break a thermometer and you shouldn't go and sniff it, you're not going to really see, expect to see effects at that kind of a dosage, and particularly not at the dosage of, ambient air concentrations. But once it gets into methylmercury, once it gets into the food chain, you have a problem. Now, think about sort of what's happened over the last several sort of decades in terms of where mercury is coming from. So you have mercury that's used in products. Mercury has been used for millennia. I mean, in cinnabar ore, which is the really red rock, used as a dye. Mercury was used in hat making. It was used in mining all the way back to the Roman times. So it's a very useful substance. But one of the really recent things that's happened is that mercury is also a contaminant in coal. So if you look at what's happened in the Arctic, you can look at sort of the concentrations. This kind of squished. But if you look at, this is sort of normalized to levels. You can look in various different archives. So what happens when they find the unfrozen polar bear? They can actually look at, what the concentrations are in the unfrozen polar bear that died in the 1200s over here, that was stuck in the ice, and then they found him, as opposed to current day polar bears, as opposed to, the museum polar bears that they killed in the 1800s. And you can track that with things like falcon feathers and ringed seal teeth and various things. Yeah.
What exactly does the percent concentration mean? Surely human teeth are not pure mercury.
Right, so it's normalized to present day levels at 100%. So because the concentration, and just to show everything on the same scale, because the concentration in polar bear hair is obviously different from feathers, is different from teeth. So with 100% present day concentrations, this is how much it would have increased. relative to. So, we can do modeling of what happens in the atmosphere when you emit mercury, and it blows around all over the place. This is what the global cycle looks like. It comes from some of my modeling work. But again, you're looking at in the Arctic where there aren't a lot of sources, you have a lot of increases, you have health effects that, you can estimate hundreds of thousands of newborns every year, so there's growing scientific concern about this substance. Now, okay, so now what do you do about it? You've got mercury used in a whole range of different products. You've got mercury coming out of coal. You want to figure out how it gets into the atmosphere. So you do something like an emissions inventory, and this is what the UN Environment Program put together on anthropogenic emissions to the air. Coal being about a quarter. This is this artisanal and small-scale gold production. I'll talk a little bit more in detail about that and how they get their mercury later. The really interesting part about this is we didn't realize that was such a big chunk. I've been working on mercury for over 10 years now. 10 years ago, that wasn't even in our inventories. So realizing how much mercury was actually emitted to the global atmosphere from these gold mining communities was actually a big step. And you've got a bunch of other different kinds of uses of mercury, uses in the chlor-alkali industry. Disposal of waste from mercury-containing products is a chunk of emissions to the air. Also important in emissions to water, releases to water. Cremation is always an interesting one. You got mercury in your teeth. Guess where that goes? Yeah.
Being a heavy metal, what's the mechanism by which, like, say it's someone mining for gold, like, I'm assuming it has to be, like, highly atomized to be able to go into the atmosphere and travel the ways?
So mercury is a funky heavy metal. It's the only one that's liquid at room temperature. So you've got, like, elemental mercury that you can basically thermometer kind of elemental mercury. And if you put that in a pan with gold, it'll form amalgam. And then all you have to do, you take that amalgam, you burn, and mercury will burn off.
There's a burning process they do.
Yeah, so sometimes that's done in gold shops. And I'll talk I have a slide later about the process and where the mercury goes, but that's essentially the principle, and that's why it goes to air. Of course, there's going to be some rinsing going to, and that's why that number's real uncertain, because again, this is a sector that's not very regulated and sort of ends up where the mercury ends up. So.
No, why was it overlooked? What changed that made it show up in the radar again?
So it was whether it goes to air was the question, and what fraction and how much is used. So there weren't very good estimates because this is generally kind of an illegal sector in a lot of places, or at least an unregulated, informal one. So that it may actually have increased over time because of the price of gold. More people are actually, there's more money to be made in mining gold, so, more use of mercury. And then what fraction you assume of how much people actually keep versus how much they burn off has changed over time. And just the difficulty, and it's pretty easy to get coal statistics. It's kind of harder. Actually, I was one of the first ones to actually put an estimate into a global model of artisanal and small-scale gold mining. And what I did is I just took the total amount that was used, which we had estimates of, and I said, okay, these are the countries in which it's used. I'm going to assume 30% goes to the air, and I'm just going to grid it because I didn't know what to do with it. Now we have a little better handle on it, but yeah.
Along the same lines, do you anticipate there being a major discovery that'll change the mix that you have showing on this slide?
Probably. I think we could. I think that artisanal and small-scale gold mining we could learn a lot more about, and the uncertainties are huge. So we're doing some work with the modeling and also looking at measurements in the atmosphere to try to back calculate what the emissions are. One of the key uncertainties in emissions is that when you emit mercury, it doesn't stay because it's a volatile heavy metal. Weirdly enough. So when it goes into the soil, something like lead will stay there, but mercury pops back up. And because we've been emitting mercury for decades, centuries, millennia, there's mercury enhanced in the surface ocean, enhanced in the soil that keeps popping back up. We don't have a good handle on what that source is and how much of it is human versus natural. So this actually, I did the human in red, and then sort of it's technically pre-industrial. But the problem is, so there was a recent paper that came out that said, yes, mercury circulating in the system has gone about a factor of 3 since pre-industrial, and we can use lake sediment cores to figure that out. But again, the Romans used mercury, right? So labeling pre-industrial equals natural is kind of problematic, because although we've had a real big spike from coal, there's probably human mercury that's been circulating that we don't have a good idea. So they're saying maybe it's a factor of 7 now, as opposed to a factor of 3. But regardless, current emissions play a role. And if you look at deposition to the U.S., this is mercury actually coming down in rainfall, entering the U.S. environment. What you see kind of a bunch of patterns. So the highest wet deposition in the U.S. is actually in Florida, and that comes from global sources. But you can see that there's also deposition in the Northeast that comes directly from the coal power plant. So I'm not going to go through all the chemistry of this because it has to do with chemical reactions in the atmosphere, but the upshot is that if you want to reduce deposition over the U.S. in all these different places, you have to tackle both the local sources, because some of it actually deposits right near the source, and some of it circulates globally, and the global atmosphere deposits and then actually affects you. So this was really one of the motivating things for the U.S. to get involved both in mercury policy nationally and mercury policy globally. So just giving you a little bit of the history, I'll talk a little bit about what happened in the U.S. As well. But this is something that's come up in the last sort of 15 years or so. The first global scientific assessment of mercury that sort of gave this idea that mercury is a long-range problem, global action is necessary to address it, was the main conclusion that came out in 2002. So you get this group of scientists together under the UN Environment Program Chemicals Division, and they say, mercury's a problem, global action needed to address it. Okay, now what do we do? And so the global treaty, as I said, was last year. Now that's a long stage. That's 11 years difference. So what happened during that time? Well, what happened was a lot to do with the U.S. And this shows sort of the influence of domestic regulation in the international context. Those of you who remember 2002 in the U.S. administration wasn't so pro-international environmental regulation. Didn't really like the idea of signing up the U.S. to something that might be questionable in terms of its cost-benefit ratio and, why mercury? International cooperation wasn't necessarily a priority, international environmental cooperation even less so, and the idea that we shouldn't waste time getting everyone on board, we should just do what we want to do with the willing partners, was an idea that was sort of widespread in the administration, so they applied that to mercury as well. So what they have is the Global Mercury Partnership. And they said, let's get together various, coalitions that are going to attack different aspects of the mercury problem. So they had a task force on artisanal and small-scale gold mining. They had a task force on coal-fired power plants. And they did some voluntary activities, capacity building in different countries to try to reduce emissions. But, there was an ongoing discussion about whether that's actually effective at reducing the mercury problem or not. It's pretty much keeping the mercury levels constant at this point. And the European Union in particular was very in favor of a global legally binding treaty, and had been since 2002. Now, so every year and every 2 years actually, the UN Environment Program Governing Council meets. The Governing Council is the environment ministers of all the nations. And they're the ones really that would set a mandate to actually negotiate a global treaty. It would be done under the auspices of the UN Environment Program. Every 2 years they met, and in 2003, the U.S. said, nah, let's do a program. 2005, yeah, not so much. U.S., now let's strengthen the program. 2007, still nothing, although a couple of other countries are on board by that time. Latin America is actually really interested in doing something, particularly because of the concerns on artisanal and small-scale gold mining. Canada also has its phases of liking or not liking international regulation. In the organic pollutants example, the last convention, Canada was very much in favor of negotiating something. Canada mines a lot of metals, not necessarily mercury, but Canada was a little afraid that this was going to be a global metals treaty and didn't want to really push for it so much, so Canada wasn't pushing. Australia, again, up and down, but likes its metals too. So, you know, you didn't have a lot of developed countries kind of pushing. You had some developing country blocks getting on board. So you think about, you know, what countries and what their different motivations are. And then we get to 2009. And suddenly in 2009, you have the European Union still saying we need a global treaty. By then, Latin America's on board, we need a global treaty. And now you have the US saying, hey, that's not such a bad idea. Guess what? We had a administration change. One of the things that is important to note about the US is that President Obama has made mercury a kind of pet issue. The U.S., and I'll talk about mercury and products and how it relates to the treaty, has a mercury export ban. That came in the mid-2000s, so 2000, I think 2000, when it entered enforcement, it was passed. I'm not 100% sure, but the sponsor of that legislation in the U.S. Senate was Senator Obama. So he had a interest in mercury in general, and also the U.S. had gone through about 8 or 9 years of trying to regulate mercury from coal-fired power plants under a court order under the Clean Air Act, and had kind of messed it up under Bush. And when Obama came in, the Clean Air Mercury rule had been thrown out of court, and they had to go back and do it again. And so Obama, being interested in mercury, said, okay, let's regulate again. And the mercury and air toxic standards came in 2012 in the U.S., but that was well underway. So the U.S. starts saying, hey, this isn't that bad an idea, because if we want to solve our mercury problem domestically, we need both international and domestic action. This is kind of a win. It's also a political win, because protecting babies and not having mercury in our food is a kind of clear public message as well. China, yeah.
Can you speak a little bit more about the cost-benefit analysis and what type of decisions the politicians and some of these people are making to make them more attractive to this type of
I can. I'm actually doing a lot of work on that in my group right now. So what they did for the cost-benefit analysis for the mercury and air toxic standards, it was a little bit of an end run around the idea of cost-benefit analysis, because what they said was, we're going to regulate mercury. It's going to have benefits, particularly on sensitive groups. So in terms of overall, like, economic benefits, it was hard to get that number up in terms of, a strict cost-benefit analysis, because the people who are most harmed by mercury are people like subsistence fishers, who eat a lot of local fish, particularly for the domestic. A lot of general public gets their fish from, 2 cans of tuna from the Atlantic, the Pacific. That's going to respond to global emissions and not local emissions. So in the U.S. context, where you have to do a cost-benefit analysis, they ended up showing the cost-benefit of the mercury and air toxic standards passed the cost-benefit analysis because of the particulate matter benefits. Atmospheric particulate matter contributes to cardiovascular impacts, respiratory impacts. You can show a lot of deaths if you reduce it. Multiply that by a value of statistical life, you've paid for almost anything. And that's what they did for mercury and air toxic standards. Now, our group's actually doing a more thorough benefits analysis of the mercury and air toxic standards out to 2050, and we get some reasonably big numbers because we look at sort of we look at both the Minamata and the mercury and air toxic standards, the global and the regional, but that work's in progress right now. But as far as what they needed for the regulation, that's what they did. Globally, they didn't really do a cost-benefit analysis. It was, we need to regulate. We're kind of agreed that this is a problem. Let's go with it. Partly that's because a lot of other countries don't have the tradition of requiring cost-benefit analysis that the U.S. does. So hopefully that gets to your question. Yeah. So again, China. China's about half of global emissions of mercury right now. China wasn't particularly thrilled about this whole thing, but China came around. Again, the U.S. and the EU and Latin America, you get three major blocks. Canada came around too. Australia came around. Africa didn't really have anything against it. They're probably a net gain of resources from this kind of analysis. So, it's China and India really who are the most worried about what they have to do. And in response to China, they delayed a year when negotiations were going to start. So they didn't start till 2010. That was also, China wanted to delay them a year because China was putting in its own mercury regulations for its power plants as part of their next 5-year plan. So China does have mercury regulations. They're not particularly binding, they're not particularly strict, but they copied Germany's and said, let's put mercury in our regulations. They do actually have quite a bit of technology on their power plants. Whether it's operating or not is another thing, but in terms of build-out capacity, they're there. So actually negotiating the instrument took 5 negotiating sessions, signed in 2013. Now, once an international agreement is signed by countries, they have to go and ratify it, make it consistent with their U.S. law. That in the U.S. Usually has to go through the Senate. In this case, it did not. The U.S. accepted a procedure equivalent to ratification, the Mercury Treaty, becoming the first party, because it was so consistent with U.S. law that it essentially was an executive decision. The administration said, we don't actually need to do anything. It's pretty much an embodiment of U.S. law because we're doing so much on mercury. This does not go much further than the U.S. already goes. So that's one particular lesson, is that the U.S. and the EU in particular, and you could see this also in the reading about the EU. These national laws often are sort of leading the international standards. And it's actually predictable in the sense that you're not going to get countries like China, countries in Africa to do the same kinds of end-of-pipe expensive power plant controls that you might expect in the U.S. when they don't even have the basic controls, or maybe don't even have power plants to begin with. So again, thinking about it's sort of a lowest common denominator that you often get in these international agreements. So one sort of emphasis of the agreement was emissions. And I'm not going to talk too much about emissions given what you guys are interested in. Again, that's the power sector part. But that was only one component of the treaty. Another is mercury in products and processes, which I think is sort of probably more interesting to you guys. And so I'm going to talk about products and processes, and I'm going to talk about what they did with artisanal and small-scale gold mining, because those both have kind of supply chain type issues. So where do you see mercury in products and processes? So one that is pretty familiar is thermometers. So again, phasing out in places like the U.S. You don't see them that often, but thermometers, blood pressure measuring devices, some of the old, those sorts of old thermostats have mercury. So this whole idea of electrical control and switching, measuring and control, batteries, older batteries, again phased out in the U.S. and the EU, but not common elsewhere sometimes still. Lighting. Fluorescent lamps. Both regular fluorescent lamps, so the tube versions, and compact fluorescent lamps. So save energy on balance, but use a small amount of mercury. LEDs don't have mercury, but again, with people encouraging more and more compact fluorescent and fluorescent use in lighting because of their energy efficient properties, mercury becomes an issue, and safe disposal becomes an issue. The other is your teeth, dental amalgam. So again, you know, some countries have phased out the use of mercury in fillings, others don't. It's pretty cheap. It's even in the US, you know, if you actually go to the dentist and you need a filling and they say, do you want the silver one or the white one? And the white one's like a lot more expensive even here. So think about if you're in a developing country, what your option is. Your option is probably no dental care at all, but the silver filling is probably much better to have. You save your tooth than, you know, the white filling, the composite, which is much, much more expensive for you. So, you know, use of mercury and dental amalgam was, you know, are we going to keep using it or not? Again, can be an environmental issue when people get cremated and get across borders. And then there's a bunch of other things, chloralkali plants, so use of mercury in processes and in industrial processes that are phased out in some cases, but not in others. Vinyl chloride monomer, particularly in China, mercury is used. So you've got a substance that you think, okay, mercury, it's a really concrete thing to regulate, but then think about all these industries that you've now involved, right? So you've got a group sitting in negotiations. I actually took a group of 10 graduate students to the final negotiating session, which was in Geneva, and you've got a group, people, maybe 75 people in the room, you know, representatives from all the different countries. Industry could come in as observers, but again, if you're an industry that does this, think about how long and how intense your observation had to be, right? You know, you're going to send a person to every week-long meeting during 5 negotiating sessions through 2010 to 2013, you know, spending a week in Geneva each time just to think about, you know, if you're in the electrical control and switching industry, to raise their hand every time electrical control and switching comes up. And they're not really even allowed to raise their hand because the only people that are technically allowed to talk on the floor are countries. So what you can do as a electrical control and switching person is you can go and lobby your friendly countries. You can put out a poster in the lobby and say, hey, this is how these regulations would affect us. There's probably somebody next to you that says, we have the mercury-free version. Come buy it, you know. And so depending on your country and sort of where you are, this is what it looks like. In the products group, it became a little bit more informal. You know, there were companies that participated in discussions as observers. You know, they talked about thresholds of, you know, where mercury would be restricted or not, and the companies started saying, well, there's an alternative for this, but there's not an alternative for this. So as you think about, you know, the major categories, you have ones that are a lot in developed countries, and then ones that are primarily in developing countries. And these are things that used to be in developed countries quite a bit, but have often phased out. So how do you think about regulating something internationally? Now, there was 2 different approaches, and they referred to them as positive and negative lists, which is a little bit confusing because it meant the opposite of what you might think. But the idea is that you either say, I'm going to list all these things that are banned and you can't use mercury in them, or I'm going to ban mercury in all products and I'm going to make a list of the ones you can still use mercury in. So the idea of banning mercury in all products was kind of a non-starter because, again, things like compact fluorescent lamps had benefits that were greater than, you know, the cost of mercury. You know, actually, no one was really suggesting that you go back to incandescence because if you have they've actually done the assessment that if you actually, you have a very heavy coal load in your power, the mercury that you save by going to a compact fluorescent is much larger amount than the mercury that's actually in the light bulb. And there's a move to get less and less mercury in that light bulb. So the idea that they came up with was, there was a lot of discussion. Do you have the blanket ban with the exceptions? Do you just list the ones that you're phasing out and banning? And they came out with a latter approach. But then they had to negotiate which of these things on this list was on there, which was exempted, and if there were thresholds to each of these. So what kind of level of mercury would you accept in these or not? Yes?
I was wondering why they would go about it that way, trying to create an exhaustive list when they don't know future technology that's going to come out, rather than setting out a set of criteria that's saying if the product meets A, B, and C, then you can do it.
Who decides on those criteria, right? So, or actually reviews whether you actually met those. And part of that is transparency, right? So what countries have to do is then go back to their countries and say, okay, what am I allowing, what am I not? You have to sort of know what you can put mercury in and not. So there's kind of a transparency approach that happens. I think the two options that came up, the either blanket ban plus exceptions or the, we list the things that we're banning, were kind of the two approaches that they most looked at. Because again, that would make it even more wishy-washy, I think, because then you could show, oh yeah, well, I fulfilled these 3 requirements. Right? So that wouldn't be that stringent in the international context because there's no body that can really certify those requirements. So the key with international regulation is that there's no enforcement, essentially, right? So, you're not going to, it's an environmental treaty. Like, you can barely enforce the ones that actually involve weapons. Like, you're not going to go bomb someone that, is using too much mercury. What's going to happen is you're going to say, hey, you're using too much mercury. We're going to, we're going to caution you. We're going to shame you in the international context. We're not going to let you vote. Maybe we'll actually give you more money because probably the reason that you're not complying is because you can't afford it, right? So that's really what happens, yeah.
The topic from your eternal wonder. So I come from France, and we have an island in the French Polynesia called New Caledonia.
Mm-hmm.
The island basically has a lot of copper. And so copper is the main industry there, and to say the only industry. And basically the rivers that were blue once have turned red because of mercury.
Mm.
The level of contamination of the rivers in the island that was a paradise is extremely high, and it's still the only industry, so it's the main and only source of employment in the island. And there's nobody who says anything about it, or nobody would tend to do anything about it, because I feel that if it's not a consensus, there's still an understanding that it's the only way the island can have any income. And there's nothing developed. The tourism is not developed. It's really level 0 of development, except for this. So how would you go about it? Because when I was there, I was really sad to see that such a beautiful place could be damaged with nobody really wanting to do anything.
I think that's really sort of the larger challenge that you see in these global environmental negotiations, because you have a lot of places like that with various different specifics, but the idea is how do you balance benefits to people, like building energy, versus environmental damages. And the solution that the international community does, I wish I had a better solution, but it's basically throw money at the problem. Capacity building, different techniques, try to get cleaner processes, build awareness. That's pretty much the...
How can you build awareness? Because it's a small island that is probably doesn't mean a lot to the big countries, or...
I think a lot of it's local awareness too. So in Mercury and
locally.
Yeah, so in the Mercury negotiations, there was a lot done So a lot of the non-governmental organizations have sort of banded together internationally into a more mega group. So you have some local non-governmental organizations who have kind of partnered across in like Mercury Action Network or something. I forget exactly what it was called. But that was an umbrella group of a bunch of different, very local non-governmental organizations, a lot of whom work in these like artisanal and small-scale gold mining communities, which is actually sort of very similar to this kind of issue, which I'll talk about next. But yeah, the idea is that you can do awareness-raising workshops. So they bring in international experts, national experts, talk about the damages of mercury, talk about what you could potentially be doing about it. That's sort of where the state of the art is, I think, at this point. But yeah, so you had to go through, these major categories of mercury use. And then I just want to flip ahead a little bit to actually what happened. Again, you have different phase outs and phase downs, and then there's this very legalese exemption period where you can have either general exemptions or specific exemptions. Another area where mercury was generalized exemption was mercury use as a preservative in vaccines. So that was one that, again, this sort of cost-benefit analysis, there's no evidence that it's harmful, again, other than the general sense that we want to phase down mercury, but it's been phased out for precautionary reasons and also because, again, don't want to use too much mercury in developed countries. But what happens is in developing countries, you have vaccines that it means it doesn't need refrigeration if you use a mercury-containing preservative. So again, you're getting vaccines to places where you don't have refrigeration if you use it. So that's why that ended up in a general exemption.
Well, as you go through this process, and when does the science get into the discussion? Because you have at some point, the scientists did all this analysis. They know exactly what levels should be allowed, and they want to just reflect it. So I'm wondering where does this get in?
It's a lot less technical than you think it is. So where the scientific analysis came in was really in that, global mercury assessment in 2002 and the updates of that. And then the negotiators said, okay, yeah, the scientific case is made that we ought to reduce mercury. There was no particular substance by substance sense of when they actually thought to phase out. No one did an analysis of what the benefits of phasing out in switches and relays versus linear fluorescent lamps. That just wasn't even on the radar screen. There were assessments that said, where are the sources? Where does mercury go? But then it was really a horse trading kind of thing. I'll give you switches and relays if you give me cosmetics. Because each country wants to sort of protect its own interest there. Some might have mercury-free alternatives that they might want to sell. Others, it might be a particularly pressing issue, like this cosmetics. It might be a particular public health issue in countries and in regions. Mercury is a component of skin lightening creams, some skin lightening creams, which have been, people have tried to ban them. But again, countries with less of a regulatory infrastructure, it actually, again, putting mercury directly on your skin, not a good idea, and can be a big public health problem in some communities where there's an interest in using these things, sort of culturally, and also in cultural practices like use of mercury in religious types of practices that can be kind of dangerous. So those cosmetics, again, greater than 1 ppm. Also topical antiseptics, pesticides, biocides, that kind of thing. Use mercury to, again, toxic, kill the bacteria. There's other ways to do that. But again, in countries where you can't really control import very well in terms of your capacity, international regulation can be an end run around that to think about. So and again, for dental amalgam, there was a goal of phase down, but again, no set date. So to the extent that you can, use the more expensive but more environmentally friendly alternatives. And that actually ends up getting into the environment quite a bit. Story in Massachusetts, when they required dental separators in dental offices, it used to be that they just flushed the stuff down the drain when they changed your filling. They required dental amalgam separators. You can actually look at that date and look at the mercury level in fish in the waterways of Massachusetts, and it goes dramatically down right after that. I mean, it actually does wash right into the waterways. Again, it's a lot of mercury that's in a particular filling. Yeah.
I may know the answer for this as well, but when they pick a date to phase this out, 2020.
Yeah.
Is this just sounds good, or is there?
Yeah.
Is there some?
Sounds good.
Sounds good.
I mean,
just make it far away. Not next year, not 2 years, something that.
And it's negotiated, right? So, people that want, again, a lot of these things are phased out in Europe, right? And so the companies have figured out a way around them. Europe has an interest in getting these things globalized because they have very strict regulations like we and like Rose that talk about what you need to sell products in Europe. And to the extent that that becomes a global regulation, that obviously favors, Europe thinks it's the right thing to do, first of all, but also it makes it a global standard as opposed to different standards throughout the world. So, you've got countries, European countries often pushing for earlier and earlier phase-outs. Now, maybe China, for example, which actually produces a lot of these complex fluorescent lamps, probably wants later phase-in dates, right? So 2020 emerges as a kind of compromise. Again, thinking about the timing of actually entry into force for a treaty, I think you need 50 parties ratifying. U.S. ratified really, really quickly because, again, it just said rubber stamped it. It's the only country to ratify so far. You've got, so conservatively, at least 2015 before it enters into force. So setting a date before that would be kind of weird. So, yeah, you have to phase it out before you actually signed it. So 2020 is a relatively early date in this area. Mercury mining is phased out also under the treaty, and it's 2035. Or no, it's 15 years after. I think it's 15 years after entry into force for that particular country, or something like that. So it can be quite a long time. So going back a little bit. Talking about mercury trade, so this just gives you a sense of where mercury is flowing and where it's going. Again, since we've had the Mercury Export Ban Act, but this is actually just of commodity mercury. So this is just mercury as mercury. This isn't mercury in products. So the compact fluorescent bulbs that we import from China are not included in these flows. Yet primary mercury mining in Kyrgyzstan, they're actually closing their mine, partly because of U.S. assistance. China has no interest in actually closing their mine, although they will have to under the treaty if they ratify it. But China's mostly using it itself. So the mercury that gets used in products, so you don't see much of an arrow there coming out of China because it's not internationally traded. But again, a lot of flows for a lot of this mercury is coming from recycled mercury, mercury stocks, mercury in use. So you got mercury flowing as mercury, then getting incorporated into products. You get obviously the trade in products, and then trade in wastes. So once product is no longer useful, what do you do with it? I say that the mercury is a full life cycle convention. It does actually sort of yield a lot of the waste issues to the Basel Convention, which deals with wastes internationally. So that is pretty much sound. It has sound guidelines of transboundary movements of hazardous waste, and that pretty much covers the mercury. So they tried to make that consistent. Problem is that it doesn't have the same set of parties, but in particular, the U.S. is not a party to the Basel Convention, but pretty much does the required things that the Basel Convention does. I mean, in the sense of being able to deal with hazardous waste in a reasonable way.
That if they cut off the influx of mercury, that they will only be stuck with trying to manage their own creation of mercury.
Right, and to the extent that they actually use mercury, I'm not sure exactly what the use of mercury will be, but again, trade is restricted under the treaty. U.S. already has an export ban. EU has an export ban. Mercury trade will only be allowed for exempted uses. So if you're making one of those exemption processes, like dental amalgam, that might be Australia, right? It might just be importing for teeth. Who knows? But again, if you're using it for an exempted use, it's okay. If you're not, it's not. And that sort of actually is a really good segue into the artisanal and small-scale gold mining story. Because, again, thinking about where mercury goes and where mercury is in trade, artisanal small-scale gold mining is a really big deal in a lot of countries, big emission. But the question is, how do they get their mercury, right? You're a small-scale gold miner in a developing country. You need to buy mercury, right, to figure out how you actually mine your gold. So this is a figure from a paper that looks at what the artisanal and small-scale gold mining process is and how that relates to the gold supply chain, which I thought would be interesting for you guys. So you started at the top with mercury exporting countries. And a lot of those exporting countries think they're exporting to dentists. So one of my colleagues works in the artisanal and small-scale gold mining area, and he showed this picture of an artisanal and small-scale gold mining community. And it was Mercury Dental Shop. Like, yeah, right. You're a Mercury Dental Shop. You're in a gold mining community, right? But in a lot of cases, they'll buy mercury from dentist or a dental middleman and actually sell illegally to the miners. So then you're the miner, miners over here, they dig your pit, you get the ore, and then mix it all together. So then what you're left with is some mercury amalgamated with gold, and you've got some waste. And that's where you have this amalgam ball, and you have the waste. Now the waste is going to have some rock in it, it's going to have some water, it's probably going to have some mercury in it because you couldn't, get all of it to stick to the gold. And what do you do with that? You just dump that. So you release mercury-laden byproduct into the waterways, which could have local impacts, but probably not going to enter the global pool because, again, you just rinsed it out into your local place. It might. We don't know the science on that. But you've got your amalgam ball, which is most of your money, with your gold, but it's bound up with the mercury. So what do? You can do a couple of things. You can burn it yourself. So this would be the sort of artisanal part. You're actually going to just get a pan. You're going to light a fire under it, and you're going to let the mercury burn off. Now, that's not particularly efficient, but it's probably the cheapest way you're going to do it. Now, one of the ways to minimize the mercury loss is to have a retort. So basically, you have a little cap on it. You have, the mercury condenses, and then you drip the mercury back into a little cup. You could use the mercury again. It saves it from going into the atmosphere. It also saves you some money because you don't have to go back and buy more mercury or buy less of it. So that's been one of the things that has come up in trying to minimize the mercury lost. But again, as you think about it, not the most healthy place in the world to be, breathing over a artisanal or a burning mercury pit. Again, lots of local issues. So you've got, this AGSM product. You usually, sometimes that burning can happen in sort of local shops as well. That's more of a small scale. So you take your amalgam ball to your local shop. More efficient. That guy's got to get a cut. So, you think about that. Depending on the community, that might happen. Usually a buyer can double as a mercury dealer. Buys that sort of intermediate gold product, does a final burning step that makes it more pure gold. Then you enter the regular gold supply chain, And you end up with, on the market, about up to 30% of artisanal and small-scale gold mining gold that then goes to a combination of jewelry and investors and industry. So it really is not an insignificant amount of gold on the market that comes out of this process and involves mercury. So again, with the price of gold the way it is, this is something that has a lot of influence on the livelihood of people who are involved in this. So it's a development issue. It's a local community issue. It's also an international market issue. And you can think about different, so, there's a lot of different certifications that come into gold. Some of which, at least one, I forget I don't have it in my notes, the particular ones. But some of which actually, one of which does incorporate mercury into the certification standards, and one doesn't. So there's a difference in, there's a couple of different, like fair trade, fair mind, that talk about, the conditions of the miners and various things. Whether or not and how they cover mercury is an open question. So will that help if you have more of a certification process? Not sure. Now, how does the treaty deal with this? Well, it has a number of provisions that really boil down to essentially capacity building. Suggests that these, to the extent possible, these sectors be regulated and sort of formalized because they're often informal sectors. Again, illegal mercury, black market mercury, essentially, that's from dentists. That, the types of technologies that can prevent the releases of mercury and make it a little safer be adopted in a more widespread basis. But again, it's not eliminating artisanal and small-scale gold mining because that is a livelihood for a lot of people. It's trying to make it less mercury dependent and less toxic, both for the miners and for the environment. So, they've basically estimated that they could probably halve the amount of mercury based on these estimates. So there's a lot of opportunity for reductions, again, because a lot of these processes are really inefficient. So I want to just end with talking about sort of the general context in which this mercury regulation is happening, which is sort of the overall international regulations and what's happening sort of globally, because obviously these producers and people who are dealing with mercury-related issues aren't just dealing with this as an international environmental issue. There might be other chemicals, other different kinds of considerations. So this is a figure that one of my students put together after going through the negotiations of all the different international organizations that kind of had a role in the Mercury Treaty. And one really obvious link is through the existing chemical treaties and institutions. So the Stockholm Convention is on persistent organic pollutants, so a lot of pesticides, DDT, PCB, industrial chemicals like PCBs, also regulating dioxins and furans internationally. The Rotterdam Convention is on trade in hazardous chemicals. It's a prior informed consent provision, so it mandates that countries that are taking imports of hazardous chemicals must give their informed consent prior to that chemical being exported. This is trying to prevent the idea of, something's banned in the U.S., the U.S. decides, well, you guys will use it, we'll take it, so let's just export it to you. The idea is it shifts the burden to the exporting country to make sure that that country knows what it's getting and knows that you think it's dangerous. So there's a list of chemicals on that convention. Again, that's similar to the prior informed consent process that's in the Basel Convention that deals with wastes. So again, there's potential synergies there because Rotterdam and Basel also have, things potentially containing mercury and also this issue of trade. Funding often comes from the Global Environment Facility, which is basically donations from the rich countries. Minamata Convention has an additional new designed specific funding mechanism to be negotiated fully. But that has to do with issues that developing countries in particular have with the Global Environment Facility and its responsiveness. So that was negotiated as kind of a hybrid compromise. Possibly, some multilateral funds that actually influence other environmental negotiations. But you have a bunch of other international organizations like World Health Organization that sets guidance for mercury levels in fish and also is involved in the vaccine thing, related to the dental thing. So thinking about, connections with that because you get a very health relevant issue. International Labor Organization, obviously in particular the miners, and what people are exposed to in particular factories is often an ILO. Food and Agriculture Organization, to the extent that involves pesticides, that's one that comes up. So then that's sort of the international bits. You've also got a bunch of sort of guiding principles that come out. The idea that you can do whatever you want to your own environment, but you have to watch out with others comes out of the Rio Declaration. That's 1992. There's the general discussions over sustainable development. These all kind of inform in a general way the kinds of regulations that are developed under the Minimum Convention. Talks about things like the precautionary principle come out of these guiding principles. And then, of course, you have multilateral regulations, domestic agreements, bilateral agreements, regional agreements that are also dealing with mercury, but on different levels and among different countries that may or may not be consistent or not. Again, domestic governments try to make it as consistent as possible in the negotiations, but everyone's trying to do that, so it might not be possible. So that's sort of the that's all I had for prepared slides. I was told to keep it to about an hour. I think I made it and open it up for discussion after that. Yeah.
Just wondering what happens to mercury once whoever's doing the proper disposal gets it. Do they convert it to some safe chemical? Do we put it in barrels and bury it under a mountain in Nevada?
The latter. Mercury's an element. Mercury's an element. You can't get rid of it. So not much you can do about it. The nice thing is the quantities are pretty small. So again, encapsulating it, burying it in barrels is pretty much what you want to do with it. Again, you're talking about tons per year. When you're talking about carbon, it's like gigatons per year. Mercury is in actual tons per year, and mercury's pretty dense. So this is also why your clump of mercury in your tooth or in the thermometer is actually pretty significant, because there's a lot of mercury there, in comparison to the global budget, whereas the amount of carbon is teeny tiny. But yeah, I'm not sure about Nevada specifically, but yeah, you could put it in a trailer. I've seen mercury trailers, like the strategic mercury stockpile was in trailers for a while.
Sounds very secure.
But,
So during the negotiations, did you see a company that you thought was doing something right? I mean, in terms of understanding their role that they could play, because this seems pretty out of my hands, right? So as a company, at the end of the day, there's nothing I can do. I just probably can go to a local state official, voice my concerns, hopefully get him elected, and let the whole thing just kind of take course.
There were definitely companies involved, but in sort of a limited way. So, the lighting manufacturers were there a lot. But mainly I saw them talk about, their products and their minimization and, really kind of get the message that we are trying to take the mercury out of our lighting and we're doing a good job, so, don't ban us. And I think to that extent, there was a lot of awareness raising of technologies and available technologies that was done by companies in these international fora. Again, it's an opportunity to, trumpet your green technologies. So that would be sort of I think the positive end of companies kind of advocating, mercury-free alternative companies. Definitely, if you had a mercury-free something, you definitely were kind of waving the flag for it. There were other companies that were sort of there to kind of make sure that their interests were protected. Oil and gas. mercury is a small contaminant in oil and gas. Mercury is mostly a concern on site. So because of the way oil is distilled, in the final product, there's not a lot of mercury. If you have the unfortunate sort of basically location of being near a mercury deposit when you're drilling your oil, you've got a problem, but you've got a problem there, and you have to deal with it there. Because if you get mercury into your oil distillation process, it really gums up the works, as far as I understand. So the companies were saying, hey, this is not really an international problem. This is something we deal with. We would really prefer that you not regulate mercury in oil and gas in an international way. And there were a lot of countries on that bandwagon too. Once it was clear that mercury was not going to be, mercury emissions regulations were not going to be applied to oil and gas, Saudi Arabia decided that they weren't going to go to lunch. So things like that, you know. And again, awareness raising of the kinds of things that international industries do, right? So even if it's not subject to the regulation, you know, you have assessments that come up that say, what are best practices? Because, you know, your multinational companies might know, you know, this is what you do when you hit mercury in your gas deposit, but not all companies might be sort of aware of that. So again, that comes into the capacity building, awareness raising, you know, making toolboxes to figure out how much mercury you're emitting in your process. These things come out of international negotiations a lot.
The other I guess, observation as you were going through both the importance of the U.S. and European regulation to set the way.
Yeah.
So in some sense, if you do what Europe is doing, you are in pretty good shape in terms of anticipating what could become global. Is that a fair, at least?
I think that's fair, and I think that's sort of a strategic choice. So one of the things that's changed over the years, it used to be that the U.S. was really the global standard leader in international environmental things, and the U.S. was kind of a first mover in a lot of things like the Clean Air Act, pesticide regulation, et cetera. And in the last decade and a half or so, it's really been the EU. The EU is really the sort of global standard leader in the international environment, particularly in the chemicals area. And I think there's a clear effort by the EU to actually globalize these kinds of standards. You know, a strategic goal in a sense. And, you know, part of that's competitiveness. Part of that is, you know, well, we think it's the right thing to do, right? Because, you know, it makes everybody safer. And why should, if we think something's too dangerous for our population, why should it be okay for others, right? But again, with these kinds of chemicals regulations that are going in the EU, you know, you see that now. You do see pushback on that. I mean, the U.S. sort of saying, "Hey, this is too far," and it ending up in trade disputes and various things. I mean, you see that with CO2, but I think you do see chemicals versions of that. But again, you know, you see it's a multi-level thing too. In the U.S., traditionally, how a lot of these environmental regulations came to pass was that you'd have a leading state. So the U.S. regulation for the toxics release inventory, where you have to report if you release toxics, came out of really a state initiative in New Jersey first. So, you know, you get a few leader states. California does a lot in terms of leading environmental regulation. The interaction between California and the EU is actually really interesting because you see California now copying a lot of the EU regulations. You do see a lot of copying as well. A lot of developing countries, when stressed with the idea of doing environmental regulations, is, gee, what's Germany doing? What's, you know, the U.S. doing? Can we just kind of go with that? Because again, you know, the capacity to do these kinds of real technical analyses of, well, do we set it at 5? Do we set it at 7? What does really make sense? You know, a lot of developing countries don't have that, so they say, you know, that's really how China developed their mercury threshold, is took the one from Germany. I talked to the Chinese researchers that have informed that. And, there's a lot of research on mercury in China, but, we've interviewed them and they said, yeah, basically took Germany's. Seem reasonable. Yeah. And also that's going to be where we're going to buy our emission control equipment until we can figure out how to make it. So if they're going to make it for German market, we're not going to set a more stringent one, and then we're not going to be able to buy the equipment to meet it, right, until we can make it. It just makes sense with a globalized market for those things.
It's interesting you mentioned that because Brazil did the same for the weed regulation, got the European watch, copied it,
Yeah.
just like that. I mean, they just didn't, no local analysis, no country, same thing.
Yeah, but I mean, that's something that you really start to see in these negotiations. So, it's even more prevalent in climate, but even in Mercury, you see this, that, a lot of developing countries have one person at this negotiation. The U.S. delegation was about 20 people. So the U.S. would have someone from the EPA, and someone from the State Department, and someone from the U.S. Trade Rep's office, and they had some people from, they had some health experts, they had, people that did vaccines, and, so they had a broad range of expertise. The emission control people, the products people, they were all in different groups. And even in Mercury, which is a fairly small area, you could assemble that team. Now, you've got people from African countries, and you've got one person. You've got 2 or 3 groups going at the same time. You have to deal with emissions from power plants. You have to deal with, products. And, the way it works in the U.S. is, I know the people who work on Mercury, Mercury's like almost their whole job. Because they're dealing with the mercury and air toxic standards, they're dealing with scientists, there's scientific assessments going on. The person in a developing country, Mercury they're probably running the whole environment division, right? They might be running environment and labor and health, right? Especially smaller island states, you've got couple of 100,000 people in your population. I mean, how much can you staff an environment ministry? So a lot of these regional consultations become very important, but capacity really comes into play. When we were at negotiations, I mean, sort of this negotiation to exhaustion comes in too, because like you would expect, no one wants to compromise till the very last minute. So when we were there at the final negotiating session, the deadline meeting was scheduled through Friday, 6 p.m. We got to agreement Saturday morning at 8 a.m. after negotiating all night. So, if you have a couple people on your delegation, you can take naps. If you don't, you're kind of challenged. Yeah, and you miss something, right? Yeah, exactly. So again, you have to rely on other friendly countries in the region. And a lot of that is done to try to facilitate, in a sense, a lot of the African countries have a lot in common in the negotiation, and sort of bond together. But again, countries that have a very particular interest might not get that represented. And then they have to go back and figure out what it means for their own legislation in the context of all the other things that they're doing.
So can you talk again about this pace of negotiation? Because I remember I saw one of your talks about this and how exactly, kind of the dynamics of the negotiations.
Yeah.
This kind of explains.
So yeah, nothing happens until the very last minute, which is interesting. I mean, it's sort of like grad school. But, there's a lot of spinning wheels for, we have to discuss things, we have to be deliberate. Again, 2002 was when there was a, global scientific assessment says we ought to do something about it. And then, years and years. Mandate for negotiations was 2009, right? So then you schedule a meeting. Usually schedule meetings maybe for a negotiation like this every 6 months or so, 5 or 6 day meeting. Everyone has to get there. You've got interpretation issues. So the 6 UN languages are simultaneously interpreted in the main room, in main plenary discussions. Most of the in the corridor discussions are in English, because everyone speaks English, except for a few. And if you're one of the few that doesn't speak English, that's a problem. you try to avoid sending those people, but some countries don't have a great English-speaking capacity. That's been mostly a problem in my experience with French-speaking African countries. Have the most problem with finding the person who speaks English. Lately, it's been a little better. The older people often didn't speak English. Younger people are actually sort of taken over now in a lot of these countries. And so the idea of the 65-year-old person that didn't quite get the message that English was, wasn't taught English in school is no longer at the head of the delegation. It's now the 40-year-old that basically went to school in an English-speaking country in a lot of these countries. So that's one issue. Again, if your country's language is not one of the 6 UN languages, you've got to speak on that language on the floor. So if you're from Brazil, you're probably speaking English on the floor because Portuguese is not a UN language. So again, if you're from Japan, you're probably speaking English on the floor unless, for some reason you know French. But you've got to pick one of the 6. So English, French, Spanish, Arabic, Chinese, and Russian. So that's another thing that makes things go fairly slowly when you have simultaneous interpretation, and means that it can kind of be a glacial pace for a while people say, hello, I'm going to thank the chair of the negotiations, and I want to respectfully say that I disagree with paragraph 2, but in a 10-minute speech. And then the next person says, I also disagree with paragraph 2, and you have to go through everybody in the countries before they actually say, okay, you all go talk about paragraph 2 in the room over there. Once that happens and you get to a deadline, you can agree on paragraph 2 relatively rapidly, but you need that whole process of getting to agreement there. So again, writing the text, the Secretariat supports a lot of that. But again, you're drafting in a big group of people with 160 countries, going word by word through a document that has legal force. It's a tough thing. And that's why the science, I think, doesn't really come in, because the complexity of the negotiations, it's part of the reason why I think the chemicals program has set up this process pretty well, is that they sort of say, okay, we're going to do the scientific assessment, we're all going to agree, we're going to stamp it, we're going to move on. If you have a question on the science, we'll kick it back to the scientific group, we'll do an assessment, we'll agree, we'll move on. So it's kind of like, okay, the science sets the basis, and then we're going to negotiate, which means it's not always the optimal outcome, but it gets done. Something gets done. Now I did some analysis actually of what would happen in Mercury and the environment as a result of this this treaty, with the best guesses of what it would involve, and pretty much the conclusion was avoided increases. So without the treaty, sort of our business as usual would be Mercury increasing in the environment. With the treaty, probably pretty steady. So again, if you want Mercury to decrease in the environment, you've got to then go through and look at your technology regulations for emissions and probably ratchet those down through the treaty process itself. Otherwise, you're not going to actually improve. But it's also more legally and politically important at this point than environmentally important, because it sends a pretty clear message that Mercury is a pretty bad thing internationally, and that has a really big signaling sort of mechanism. If you're a company and you're thinking about using Mercury in a process, which might be the easiest way to do things because Mercury has some really neat chemical properties, this kind of thing will make you think twice about it. So that idea that there's sort of a consensus around Mercury is bad, and there are increasing amounts of regulation, and countries are beginning to figure out that Mercury's going to regulate more, has a strong sort of political force, whereas the technical regulations might not be sort of the operative part. So again, legally and politically important, not so much environmentally yet, but might be in the future as sort of amendments come in, as the technical requirements. There's a lot to be decided on exactly what technologies might be considered in terms of emissions regulations, and that's an open question right now, and it's going to be decided by the technical groups and by Conference of Parties negotiations. Yes.
So after 10 years of working on this, do you eat fish?
I do eat fish. There are fish that are relatively low in mercury. So the key is, and the key in sort of dietary advice on mercury is you don't want people not eating fish. Fish high in omega-3s, but low in mercury. Unfortunately, that's like the herrings of the world, and I don't love herring. But again, I also figure there's lots of things that are going to kill me faster, like French fries. So, I got to take them one at a time.
All right. Any more questions? Thank you very much.
All right.
All right. Okay. So we're not going to go through today your deliverables. Tony may have mentioned, or Alexis, sorry, last time that we divided your groups. Did they tell you? Yeah. So we're going to be meeting with you independently over the next few days to go over where your project is in preparation for the final report. And then next week we're going to be talking about strategy. So we're going to try to get everything we have covered and try to frame it in a more concrete discussion. So what are we going to do with everything we've learned? I mean, you're going to eventually want to drive a change in a company. How should I start? With all these dimensions, the technical side, now the political side, the NGO side, the complexity of the network you have to deal with. And we're going to have a discussion around that next time, and we're going to probably bring some of the things that you have already worked on your specific case studies. And on Wednesday, we're going to have the head of EMC on the sustainability side to actually tell us how they did it. It's very interesting. Today I was meeting this morning with, last 3 days, I've met with P&G, Intel, and Nike sustainability heads and how they have been thinking through this process. So trust me, they're as confused as probably you are at this point. Exactly what do I do? But at the end, you have to make some specific actions. So we're going to at least bring some of those ideas to the table on the next 2 sessions. And with that, I think that see you on Monday. Thank you.